Here are the materials that you will need for building your own ThunderWave ribbon. First, you will need some type of bar or rod to build your ribbon on. For my build, I used some salvaged 2 cm curved aluminum stock, but straight ribbon bars work fine as well. A variety of materials can be used for this, however, it helps if it has a bit of weight to it to keep it from jumping around too much as it is hit. Make sure that the bar is nice and clean so that the tape and glue will stick to it well. Next, you will need a 10-turn precision wire-wound potentiometer. I'm using a Vichy Spectral 10K unit that was removed from equipment as defective. With use, the wiper in these devices eventually goes intermittent, but since we just need the internal resistive element for our ribbon, this is not a problem. When the resistive element has been removed from the potentiometer, it will measure about 12 k ohms from end to end, and this is the actual resistance value that the ribbon controller circuitry is designed for. If a significantly different potentiometer resistance value is used, then the control circuit may have to be adjusted to compensate. 3 force-sensing resistors are required to measure how hard the ribbon is being struck. My build used Interlink Electronics type FSR 402. These sensors should be small enough to fit completely underneath the ribbon bar with no part of the sensor hanging over the edges. You will also need 5 different types of tape to build your ribbon. First, some copper tape is used for the electrical contact. I used some 6 and 8 mm types with conductive adhesive that are commonly available for craft use. Some double-sided sponge tape is needed as well. This should be 12 mm wide type with 1 mm thick, very dense foam rubber and very strong adhesive. The next tape is double-sided cellophane tape, about 12 mm wide. High-quality double-sided cellophane craft sheets with strong adhesive can be cut into strips and pieces and used here as well. Finally, a small amount of standard electrical tape and masking tape is needed. You will need 3 small self-adhesive rubber feet. These should be a size that fit well on the force-sensitive resistors, completely covering the active area but not extending over the edges. A ring lug and securing screw are used to connect a grounding wire to the metal ribbon bar and anchoring the electrical cable. A couple of small brackets are used to keep the ribbon from moving sideways when in use. These can be anything that will hold the ribbon in place and will depend on how you design the stand that supports your ribbon. I had some salvaged L brackets on hand and used a rotary grinder to cut some slots into them so that wires could be run underneath them. You will also need some small bolts or screws to attach these brackets to the ribbon. 2 crimp connectors are needed to connect wires to the resistive element, as these type of elements cannot be soldered. Some ordinary small tie wraps are required for securing some of the wiring. Some hookup wire is needed for the project. Almost anything will work here. You should have at least 5 different colors. Various sizes of shrink tubing are needed, including some of fairly large diameter. Next is rubber tubing. For my project, I used some 9 mm exercise resistance banding. The higher strength types work best here, giving the most bounce to the feel of the ribbon, but the size and strength is not critical. Some thin rubber sheeting is also needed. Again, exercise banding works well here, but the actual type is not critical either, as long as it is fairly thin and flexible. Flexible silicone sealant is used as an adhesive in various places, and some gel-type superglue is used in construction as well. Also needed is some plastic film. This film must be very thin and flexible, but also very strong, and must not be capable of being stretched in any direction. For my ribbon, I used some old drafting film that I had on hand. Some foam rubber is required. The type that is used in furniture cushions works well. You must be able to cut this foam into thin strips that are as long as your ribbon will be. Lastly, you will need a 6-wire cable and connector to hook your ribbon up to the electronic controller circuitry. For my build, I left the individual wires from the ribbon long enough to function as the connecting cable, slid some plastic mesh covering over that, and then slid a layer of old computer cable shielding over that. Having the silver-colored shielding on the outside gives the cable a nice shiny metallic look that matches the rest of the project. I then terminated the cable with a standard DB9 connector. Okay, that's it for materials. If you have difficulty finding some of these items, there are a lot of other alternatives that will work, so don't be afraid to experiment and be creative. Okay, let's start building our ThunderWave ribbon. The first step is to drill and tap a hole in the bottom of the bar for a grounding connection lug. This lug should be located near the end of the ribbon that you intend to have the connecting cable attached to, in order to use it to help anchor the cable. Also, drill and tap holes for whatever type of brackets you're using to keep the bar from moving around. Cut out 2 strips from your thin plastic sheet to be used later in the construction process. One strip should be the same length as your ribbon bar and the same width as your double-sided foam tape. If you're using a curved ribbon, you'll need curved strips, so use the ribbon bar like a ruler to draw marks on the plastic sheet for cutting guides. The second strip should also be the same length as the ribbon bar, but its width should be 1 or 2 millimeters narrower than the ribbon bar itself. Place a layer of double-sided foam tape along the length of the top of the ribbon bar, from end to end and centered on the bar from side to side. When the foam tape is applied all the way across the ribbon, peel the backing off. Carefully place the first plastic strip that you cut out on top of the foam tape so it covers it fully from end to end. Press the plastic down firmly all along its length to ensure good adhesion between the tape, plastic, and metal bar. A handheld pressure roller works well here to help attach the film securely and evenly. Next, you will need the resistive element for your ribbon. Disassemble your wire-wound potentiometer. Start with removing each end from the main body. Remove the electrical connection lugs and screws. Carefully pry out one end of the element with a small screwdriver. Then slowly pull the internal wire-wound element out of the potentiometer body. Gently unroll and straighten the element out into one long strip. You will notice that the element has a slight yellowish color, which is caused by the glue used to hold it in place. Use some Scotch-Brite or other mild plastic abrasive to carefully remove this coating. Be careful not to damage or unravel the fine wire from the ends of the element. When it's clean, measure the element from end to end with an ohm meter and confirm that it measures about 10 to 12 kiloohms. Once the element is reasonably straight and clean, attach a different color wire to each end with the crimp lugs. Position the crimp lugs so they are covering about 3 to 4 millimeters of the element at each end, with the connecting wire pulled in along the side of it. Make sure that you get a strong crimp connection, as these parts will be buried deep within the ribbon and inaccessible when you are finished. Use an ohm meter to check that you have good connections by measuring from one wire to the other, looking for that 10 to 12 k-ohm value minus a few ohms that the crimp lugs take up. The next step is to glue the resistive element to the plastic strip that you tape to the top of the ribbon. Start at one end and put small drops of superglue gel all the way along the plastic strip, every centimeter or so. Hold the element over the plastic strip and position the crimp lugs so that they are evenly aligned from end to end. Put one of the crimp lugs into position and hold it for a few seconds until the glue begins to bond. Then place a heavy weight on top of it to keep it from moving. Avoid getting any glue on your fingers, as it will bond skin instantly. Start tacking down the element by holding it firmly down for a few seconds at each glue spot and work your way across the ribbon, placing weights on it as you go. If you get any glue on the top side of the element, wipe it away as best you can. When you get to the far end of the element, glue down the second crimp lug. Go back and check that the element has not moved from its aligned position, and adjust and re-glue any areas that are not centered. Allow the glue to dry for at least 30 minutes. Carefully remove the weights and recheck that the resistive element is well centered along the entire length of the ribbon. Run a fingernail along the top of the element, checking to see that there are no glue spots on the top. If you feel any rough spots, try to gently scrape them off with your fingernail or a plastic tool until the entire ribbon element is smooth all the way along its length. Now check the resistive element again by connecting an ohm meter to each wire. Next, connect one lead of the ohm meter to one of the ribbon wires and slide the other test probe along the top of the ribbon from one end to the other. You should see the resistance value smoothly changing as you move the probe along, with no breaks or jumps in the readings. If there are any bad spots on the element, continue to carefully scrape away the excess glue until you get a smooth reading along the entire length of the ribbon. When you are satisfied that the ribbon is free of glue on the top, it's time to add some silicone. Place a small bead of silicone along one side of the element and carefully smooth it out with a small screwdriver blade. The silicone should be just below the height of the resistive element at the center and should taper down to nothing at the outer edge of the plastic strip. When you have completed one side, repeat the procedure on the second side of the ribbon. There should be a smooth surface sloping down as it moves away from the element with no holes or gaps, especially next to the element itself. When you are finished applying the silicone, run the screwdriver blade gently along the top of the element a few times to remove any excess. It's far easier to remove unwanted sealant from the ribbon at this point rather than waiting until after it is dried. Remove any silicone that may have ended up on the metal parts of the ribbon bar except at the ends where the crimp connectors are. Wipe any excess silicone from the screwdriver blade onto the crimp connectors on each end. The crimp connectors will need to be completely covered with silicone to cushion them against any errant stick strikes when playing the ribbon, so add a thick layer on top and around them. The silicone surface itself can be further smoothed by running a finger dipped in water carefully along it. When you are satisfied that you have a nice layer of silicone on each side of the ribbon that is not higher than the top of the element itself and fully covers the crimp connectors, you can put the ribbon aside for at least 4 hours for the sealant to dry. While you are waiting for the ribbon to dry, get out the second plastic strip that you cut out earlier and tape it down to a hard surface in a few places along its edges using masking tape. Get out the 8mm copper tape and cut a strip slightly longer than your ribbon. Leaving about 5mm of tape extending past the end of the ribbon, begin removing the backing and sticking down the tape along the center of the plastic strip. If you are making a curved ribbon, don't try to press the tape down continuously as you apply it to the strip. Instead, just apply pressure and attach the copper every couple of centimeters or so, making sure that it is in the center of the plastic strip each time. Continue applying the copper strip until you reach the far end of the plastic strip, and make sure that you have at least 5mm of extra tape extending beyond the plastic ribbon. Now go back over the ribbon and press down the copper tape firmly everywhere along the ribbon. Use a handheld pressure roller to ensure that it is flat and adheres well. Don't worry if you get some folds or kinks in the copper, as these will not affect the operation of your ribbon and are almost inevitable, especially if you are building a curved ribbon. Do make sure that you don't tear the ribbon or fold it over itself while it is being applied. Add a second layer of 8mm copper tape and then 3 layers of 6mm tape to the ribbon in the same manner. Use the pressure roller to flatten the copper ribbon after each layer has been applied. When you have completed all 5 layers, carefully remove the masking tape and lift the ribbon up. Cut off the extra copper tape at each end, leaving about 5mm excess, which you can then fold over and stick to the other side of the plastic ribbon. Next, solder some wires to the copper ribbon, one at each end of the ribbon on the side that the copper tape runs down. Try to solder the wire as quickly as possible so that the heat doesn't melt the plastic ribbon. The copper tape should tin very quickly, enabling a fast solder connection. In theory, you will only really need one wire to be connected to the copper tape. However, it is easy to add a second wire so that the ribbon is electrically connected at both ends. This way, if the ribbon ever gets a break or crack in the copper, the ribbon's operation won't be affected. When you have the wires attached, carefully set the ribbon aside on a flat surface. Try to keep the ribbon from flexing very much and do not allow it to fold over itself, as this will damage the copper tape. Once the silicone on your ribbon is completely dried, again confirm that the resistive element is working correctly as before with your ohm meter. Ensure that there is absolutely no glue of any type on the top surface of the resistive element, as this can cause dead spots on your ribbon. Clean any glue or silicone remnants from the top and sides of the metal bar. Now get out the foam rubber and cut 2 strips from it that are 5 mm wide by 5 mm deep and as long as your ribbon. Apply a series of small drops of superglue gel about every centimeter along the top edge on one side of the metal bar, between the plastic strip and the edge of the bar, starting just inside one of the crimp lugs, where the actual ribbon element begins. Ensure that the drops are not too big so that they won't soak into and harden the foam, and wipe away any excess glue. Starting at one end of the ribbon, hold the end of one of the foam strips down on the first glue drop for a few seconds until it bonds. Then continue to glue the foam strip all the way along the ribbon bar, being careful not to stretch the foam lengthwise at all. The glue should begin to stick to the foam after a few seconds, allowing you to move along fairly quickly. Once you have one side completed, move on and do the same thing with the second foam strip on the other side of the ribbon. The outside bottom edge of the foam should be even with the edge of your bar, and the inside bottom edge of the foam strip should overlap the plastic strip by a small amount. This causes the foam to lean outward from the center of the ribbon. This will help the foam to stay away from the resistive element as it is being compressed by the drumstick, so that it doesn't interfere with the electrical contact. Then carefully place a board or other flat object on top of the foam and add some weight to it so that it compresses the foam slightly. Leave the board on top for about 30 minutes to make sure that the foam bonds well with the bar. After that time, carefully remove the weights from the board, making sure that the foam doesn't stick to the board and pull away from the ribbon. Use a small brush to sweep out any glue, foam, or foreign matter from the ribbon between the foam strips. Next, place another row of small drops of glue along the top of one of the foam strips and lay the plastic strip with the copper tape on it, copper side down. The outside edge of the plastic strip should be about 1 mm inside from the outer edge of the foam, but also make sure that the inside edge of the foam is not covering the smaller width copper tape. Be very careful that you don't get any glue at all on the copper strip. The plastic strip should now be held by the foam slightly off center on the ribbon. This will be corrected when the strip is glued to the second foam strip. Hold the plastic strip in place for a few minutes for the glue to take hold. Place a row of glue drops on top of the second foam strip and attach the other side of the plastic ribbon to it by pulling it over past the center of the ribbon and holding it down on the foam, aligned to the foam the same way as on the first side. Work your way down the length of the ribbon, bonding the plastic strip to the foam as you go. When you are finished, the foam strip should be holding the plastic ribbon and copper tape centered in place about 5 mm above the ribbon element. Allow the glue to dry for at least 30 minutes. Cut a piece of rubber tubing to fit the length of your ribbon. Here again, it doesn't need to cover the area where the crimp connectors are. Apply a thin bead of silicone sealant down the center of the plastic strip and place the rubber tubing on top, keeping it centered on the strip. Wrap pieces of masking tape over the ribbon, holding the rubber tubing well centered all along the ribbon, and let dry for at least 4 hours. When dry, carefully remove the masking tape and make sure that the tubing is still attached and centered properly. Cut out a piece of rubber sheeting about 6 cm wide and the same length or slightly longer than the entire ribbon, including the crimp connectors. Lay the ribbon onto its side and apply double-sided cellophane tape along the top side of the metal bar, just below the foam strip. If you're building a curved ribbon, put the tape on the inside of the curve. Then take the rubber sheet and, making sure it's centered from side to side, carefully attach it to the tape on the ribbon. Position it so that most of the rubber is hanging up over the top of the ribbon. Try not to get any wrinkles in the rubber, but don't worry if you do get a few small ones. Use the hand roller to seal the rubber down onto the tape. Stand the ribbon right side up and connect an ohm meter to one of the resistive element wires and one of the copper strip wires. Test the element in contact by gently pushing down at different points along the ribbon and checking for an appropriate resistance reading. At the center point in the ribbon, pull the rubber sheet up and over the rubber tubing and down the side of the bar that has no tape on it. Try not to pull the rubber tubing and plastic ribbon sideways as you do this. Add tension to the rubber strip until the ohm meter registers continuity, showing that the copper strip has been pulled down to and is contacting the resistive element. Ease off the tension on the rubber sheet slowly until the meter indicates that the copper strip is no longer contacting the element. Pushing gently on the ribbon should cause the meter to again show continuity. Note how far down the rubber sheet needs to be pulled to reach this point. This will be where you want the rubber sheet to be positioned when you add the tape to the ribbon. Apply double-sided cellophane tape along the second side of the ribbon bar the same way that the first side was done. At the center of the ribbon, again pull the rubber over the tubing and down the other side and press it into the tape at the same position that you had previously determined, first confirming that there is no continuity indicated on the meter. Confirm that a light pressure is all that is required to activate the ribbon. Working your way along the ribbon from the center to either side, pull the rubber up over the tubing and stick it to the tape a bit at a time, making sure that the tension is consistent and does not make the ohmmeter show a continuity reading. This is probably the most difficult part of the build and may take a bit of practice to get right. If you have too much tension on the rubber sheet, you will get false triggers at incorrect positions when striking the ribbon. If the tension is too low, then the sensitivity of the ribbon will be reduced. If the tension is not consistent along the ribbon from side to side, then the sensitivity of the ribbon won't be consistent either. However, if you find that you have only one or two spots where the ribbon is slightly too sensitive and the rest of it is fine, then you can try gripping the top center of the rubber sheet at that point and stretching it firmly upwards for a few seconds. This can slightly lower the tension there and allow the rubber tubing to center itself under the rubber sheet, which may fix the problem. If you find that the tension is not consistent, or that the ribbon sensitivity is too high or too low, then it's best to peel the rubber on one side off again, remove the old double-sided tape, apply new tape, and try again. If you peel the rubber off and try to stick it to the same tape a second time, it will not adhere well and will probably peel back off sooner or later. When you are finished, lightly squeeze the ribbon at every position from end to end to make sure that it takes about the same amount of force to get a reading on the meter. Once you are satisfied with the rubber sheet installation, seal it down on the second side with the hand roller. If you get a few folds or kinks in the rubber, don't worry about it too much, and if you get a larger area where it doesn't stick, just use a bit of super glue to reattach that area. Apply shrink tubing to the brackets that attach underneath the ribbon to cushion them from rubbing on the stand. The next step is to install the force-sensitive resistors and complete the wiring. Measure and put marks on the bottom of the ribbon bar where the FSR supports are located on your stand so that you can install the sensors at the correct positions. Turn the ribbon upside down and temporarily place the FSRs at the respective locations. Using them as a guide, apply 1 cm long pieces of electrical tape on the metal bar underneath where their metal contact pins are located. Then apply double-sided cellophane tape to the rest of the area where the FSRs are to be placed, to hold them in position. Don't worry if the tape extends beyond the edges of the sensors, this will be trimmed off later. Attach your choice of a connector or wires to the pins of one of the force-sensitive resistors. Both of the wires used here can be the same color, as FSRs have no polarity, and so the leads are interchangeable. The manufacturer of the sensors that I used recommends using a specific connector to attach to the device, which should work well as long as the connector will fit underneath your ribbon. However, I prefer to solder the wires directly to the FSR pins and cover them with heat shrink tubing. If you decide to do this, keep in mind that this is not how the device is intended to be used, and that the heat from soldering can very easily ruin the sensor. Once you have connected the wires, carefully stick the force-sensitive resistor to the double-sided tape at the position on the bar furthest away from where the ground wire attaches. Make sure the active element is facing outwards away from the bar. Trim away any excess double-sided tape not covered by the FSR. Gently pull the 2 wires from the top side of that same side of the bar over the end and use a few small drops of superglue to tack the wires down to the bottom of the bar. Continue tacking the wires to the bar until you get near where the first FSR is located. Now tack down the ribbon wires so that they are positioned on either side of the FSR as they run past it. Don't get any glue whatsoever on the FSRs themselves. This can stiffen them and reduce their sensitivity. Apply one of the self-adhesive rubber feet to the FSR carefully aligning it to the center of the device, and continue running the wires further along the bar. When you get to the second FSR, install it and run the wires the same way as was done for the first one. Make sure that there is clearance for the wires to run past any brackets that you are attaching to your bar, and install these brackets as the wires are routed past their positions. Make sure that all of the wires are secured well to the ribbon bar, held tightly up against it at all places, and do not cross over each other. Install the third force-sensitive resistor the same way as the first two. Wire all three FSRs in parallel with each other so that you end up with a total of just 2 wires for all 3 devices. Solder a wire to the ground lug and attach it to the bar. Finish routing and gluing down all the wires until they all come together near the ground lug, and then splice the 2 wires from the copper tape together to make a single wire. At this point you should have 6 separate wires to work with, 1 from each end of the ribbon element, 1 from the copper tape, 2 from the FSRs, and 1 ground wire. As stated earlier, for my build I left the individual wires from the ribbon long enough to function as its connecting cable. To assemble my cable, I first neatly gathered up the wires. Then I slid some plastic mesh covering over them. Finally, I slid a layer of old computer cable shielding over that. You may prefer to splice in a multi-wire cable instead. Just make sure that you anchor your cable to the ground lug when it is complete. This assembly was then secured to the ribbon ground lug with some tie wraps. Cut out a pair of 2 to 3 cm long pieces of large heat shrink tubing and place them over each end of the ribbon. Shrinking them down seals the end of the ribbon and holds everything in place nicely. Make sure that the tubing doesn't cover the active part of the ribbon. Lastly, install the connector of your choice on the end of the cable. And that's it, you're finished! Place the new ribbon on its stand and start making thunder!